Welcome back to Science Modernizers. Welcome back to this video. So today we are going to see an experiment on viscosity. So let's get started. Now we have what are we provided with? We just have 3 steel balls, or let's say 3 balls having the same density, and a burette and 3 sample liquids. So I'm going to sample all my liquids. I've animated 3 different burettes, but it doesn't mean I have 3 burettes. Is one, so you can use and you range, and so on and so forth. But for the sake of time, we are going to animate the 3 burettes so that we just proceed at once. So we are going to consider that liquid burette. The first burette contains a certain liquid X, second contains a liquid Y, and the third contains a liquid Z. Now, what is viscosity? Viscosity can simply be termed in simple words on how much a liquid can flow. So the resistance of a liquid to flow is what we call the viscosity. Now we can easily see this in real life with this pap. All of us we know about pap, and let's use a normal liquid which everyone knows, water. So if I take a runway, let's say the same runway, here I have AB, and here still AB, the same thing, and I pour pap here, and here I pour water. Okay, now if I let this to fall and I time the time for the pap to leave this extreme to extreme B, you will realize it will take more time because pap is thicker than water. So that property is known as viscosity. So in other words, pap is more viscous than water. So those are some properties that you have to know. Now with this, what we want we want to know which amongst these liquids X, Y, and Z will have a greater resistance to the flow of when we are going to place our object inside. And so at the same time, we are going to use a methodology of having the terminal velocity of the balls. Now let's begin by doing the animation of the first. That is, let us see how much it will fall. Now for this, we have to give 3 marks. We are going to consider that from 10 to 20 is 10 centimeters, and from 20 to that is 10 centimeters. So 10 centimeters, 10 centimeters. So so what we do is, we know already that from here to here it's about 20 centimeters. So it's marked, so that's 30 minus 10. Now you are going to take your stopwatch. Let's do the exercise so that you should also be versed with what I'm doing, so that you follow up keenly. Now I'm going to start my stopwatch as soon as my ball enters the 10th mark. That is to avoid errors, because when I drop the ball, there are probably some, I'm not really going to have the best of the results as soon as it enters. So I'm going to leave it to flow for some time to gain some stability in its flow before I start timing the time that it would take to cover the distance from the 10th mark to the 30 centimeters mark. So let's launch. So I'm going to launch the animation. Okay, as soon as it reaches the 10, start the stopwatch. Stop. Okay, so I have 2.08 seconds. Oh, that's what I have. So I have 2.08 seconds. So that is what I have. Now let's see what the second we give. Oh, I didn't time. Let's go back. I still didn't time. Okay, I have about 1.01.02 seconds. Okay, now let's go to the next. I hope you are timing. Now for Z. Okay, let's time. As soon as it reaches 10, start the stopwatch. Okay, start. 30, stop. Okay, you have about 3.03.60 seconds. Okay, so that's what we have. Now how then do we know which of the liquid is more viscous? So I believe you must have already seen. So what I'm going to do is I'm going to calculate the terminal velocity here. Now you can do this twice and take the average value. So I'm just going to use my values here. So what we have is, what's the terminal velocity? The terminal velocity is simply the height divided by the time taken to cover that height. So what do we have? Our height there is 20 centimeters divided by the time 02.8. so do the calculations. We have 20 divided by 02.8, so it's about 7.14 centimeters per second. 7.14 centimeters per second. So we do the same thing here. So our v here will be equal to, that's our terminal speed here, will be 20 divided by 1.02. okay, so it gives about 19.61 centimeters per second. Likewise here, our v will be equal to 20 divided by 3.6. okay, so we'll give 5.56 centimeters per second. Now what do we realize? Amongst all, who is faster? So the fastest is this and the slowest is this. So what can we deduce? So since the same ball having the same density have different speeds in different mediums, so we cannot use the speeds to classify who is more viscous than the other. So from here we see that the liquid which is more viscous is liquid Z. So in order of classification, Z is more viscous than X, and X is more viscous than Y. So those are the level of viscosity based on the values of the terminal velocities. So that is how this is done. Thank you very much for watching, and see you in the next video.